Hello everyone. So in the last video what we discussed regarding the factorials, another important part in the chapter number system. Okay, so what are factorials, how do we define them, how do we expand them, and how do we solve particular questions pertaining to factorials, right? Now the chances of questions coming from this topic factorial is they're basically slim, to be very frank. In the past couple of years, there haven't been many questions from factorials, whether it's GMAT or GRE, right? Now, the another important part that we have to cover up in this chapter number system is the part where we need to understand the last digit of an expression, right? Now, this part is fairly important, and you do get questions in GMAT and GRE on regular occurrences from this topic last digit. Okay, now what we'll be doing as far as this concept last digit is concerned, I'm going to explain you how this works, what exactly is last digit, what are the things you need to remember, and what are the things or concepts you need to understand, and then we'll be moving on to the questions. Okay, so again we'll be following the same pattern. I'm going to make you understand the theory, then I'm going to make you understand how to bridge the gap between the theory part and the questions part. Okay, all right. So without wasting much of your time, let's begin with the concept of last digit. So first is, if you have a number which ends in 0, that is the unit digit is 0, and you raise this number to any power, the unit digit of the expansion will always be 0. For example, if you do 10 square, that's 100, unit digit is 0. If you do 20 square, it's 400, unit digit is again 0. If you do 30 square, it's 900, the unit digit is again 0, and so on and so forth. So if a number ends in 0 and it's raised to any power, then the unit digit of the expansion or the expression will always be 0. Similarly, if you have a number which ends in 1, for example 11, 21, 31, 41, and so on and so forth, and you raise it to any power. Now when we are using this term any power, let me just clarify here itself. So this is greater than equal to 1. Okay, we are not going with negative parts. So a number ending in 1 raised to any power will always give you unit digit as 1. Now you can prove that also. Let's suppose you take up a number, let's say the number is x and then it's 1, and let's suppose you multiply it once more. Basically you're squaring this number, so you'll be multiplying this with x1 again. Now as far as unit digit is concerned, in order to calculate the unit digit, what you'll be doing is you'll be multiplying these two ones, right? This is how multiplication works. This becomes 1 into 1, then 1 into x is x. Now you put a cross sign here, then x into 1 is x. So we can say that the unit digit is sorted. What happens to the tens place and the hundred place is not our concern, but one thing we can say of sure is that the unit digit is sorted out. So 1 into 1 will always give you 1, that's it. Hence you can say that any number ending in 1, you raise it to any power, it will always give you unit digit or last digit as 1. Now next is 5. If you have a number ending in 5 and you raise it to any power, the number is always going to end in 5. Again, you can prove that. Let's suppose you have a number, you have certain numbers, and then in the end you have 5, and if you're going to square it up, so again you have a certain numbers again ending in 5. In order to calculate the unit digit, what you will be doing is you'll be multiplying these two 5s, right? And 5 into 5 will always give you 25. Now if you're going to multiply 5 thrice, it's 5 into 5 into 5, again 125. If you're going to multiply 5 4 times, 5 into 5 into 5 into 5, it's 625, again ending in 5. If you do it once more, again in 5. So if you're going to keep on multiplying 5 with itself, the number will always end in 5. The number will always end in 5. So any number ending in 5, you raise it to any power, the resultant will always end in 5, no matter what happens. Right? And the fourth one, if a number ends in 6, you raise it to any power, the unit digit is always 6. It has the same reason as that of a 5. Let's suppose you have two numbers, no, not two numbers, you have a number ending in 6, you want to square it up. So a number ending in 6 multiplied by again the number ending in 6. Now what is 6 into 6? It's 36. So 6 will be my unit digit, 3 will be carried over. Now I'm only concerned with unit digit, that's it. Let's suppose you multiply this number once more, that is you're going to cube the number. So you're going to do 6 into 6 into 6, again it's going to end in 6. If you want to do it to the raised to the power 4, so 6 into 6 into 6 into 6, again it's going to end in 6. So basically no matter what you do, if you're going to keep on multiplying numbers which are ending in 6, you will always have unit digit as 6. Okay, so 6 to the power 1 is 6, 6 square is 36, 6 cube is 216, and so on and so forth. You can do it with 16 also. 16 to the power 1 is 16. 16 square is 256. You can do it with 26 also. You can do it with 36 also. Okay, so when you talk about a number ending with 0, ending with 1, ending with 5, and ending with 6, all these four are pretty straightforward, that if a number ends in 0, unit digit is always 0. If a number ends in 1, unit digit is always 1. A number ends in 5, unit digit is always 5. A number ends in 6, the unit digit is always 6. So these four are quite straightforward. Okay, now the next two is, let's suppose a number ends in 4 and you raise it to any power. So if a number ends in 4, there are two possible cases. First one is, let me write down a couple of powers of 4 for you. So if you talk about 4 to the power 1, that's 4. If you talk about 4 square, that is 16. If I do 4 cube, that is 64. If I do 4 to the power 4, that is 256, and so on and so forth. So what I'll realize here is that if I have an odd power of 4, that is like 4 to the power 1, 4 cube, 4 to the power 5, 4 to the power 7, my unit digit will be 4. So if the power is odd, I'll write here, if the power is odd, then the unit digit is 4. If the power is even, then the unit digit is 6. And this is true for like other numbers also. For example, if you do 14 square, it's 196. If you do 24 square, that's 576. Right? So if a power is odd, then the unit digit is 4. If the power is even, then the unit digit is 6. So remember this, 4 and 6, 4 and 6, that's it. Now, next one. What if a number ends in 9 raised to any power? So 9 to the power 1 is 9. 9 square is 81. 9 cube is 729. 9 to the power 4 is 6561. So again, it's following the same pattern as 4 did. It's following the same pattern as 4 did. That is, if the power is odd, then the unit digit is 9, and if the power is even, then the unit digit is 1. So it's following exactly the same pattern as 4 does. Right? So we have 6 numbers which we are clear of. That is 0, 1, 5, 6, 4 and 9. And I believe all the 6 numbers are quite easy to remember also. Right? We will not have a hard time remembering them. Now the 4 numbers that we're left with, the 4 digits that we're left with are 2, 3, 7 and 8. These are the 4 digits that we're left with. Let's begin with 2. So if I write 2 to the power 1, that's 2. 2 square, that's 4. 2 cube, that's 8. 2 to the power 4, that's 16. 2 to the power 5, that's 32. 2 to the power 6, that's 64. 2 to the power 7, that's 128. 2 to the power 8, that's 256. Now remember that your focus should only be on the last digit, or so called the unit digit. We are not concerned with tens place, hundreds place, thousands place. That's not our concern. Our only concern is the units place. So 2486. 2486. So you can see that we have a pattern in case of 2. That is, the unit digits have a cyclicity of 4. So they are always in the form of 2486, 2486, 2486, 2486. So for example, if someone asks you what is the unit digit of 2 to the power 23, you say, okay, 2 to the power 23 can be written as 2 to the power 4 into 5 plus 3. Now, what do we mean by 4 into 5, and why did we do 4 into 5? Because we know that 2 follows a cyclicity of 4. That is, after every fourth power, the unit digit is going to repeat itself. So when you write 2 to the power 4 into 5, which means we are covering this cycle of 4 unit digits 5 times. And then after that, in the 6th cycle, we are going only to the 3rd power. In the 6th cycle, we are only going to the 3rd power. Now, we are only concerned with unit digit. Now, what's the unit digit of 2 to the power 3? It's 8. So what will be the unit digit of 2 to the power 23? It will also be 8. This is how you use cyclicity. I'm going to take up that number, divided by 4, calculate the total number of cycles that it will complete fully. There will be one cycle which will be partially completed. Check out that number. In this case, it's coming out to be 3. So unit digit of 2 to the power 23 is as good as unit digit of 2 to the power 3, and that is simply 8. This is how you use cyclicity. So remember that 2 has a cyclicity of 4, which is 2486, 2486. Now the next one is 3. So we have 3 to the power 1 is 3. 3 square is 9. 3 cube is 27. 3 to the power 4 is 81. 243. 729. 2187 and 6561. 3, like in the case of 2, also follows a cyclicity of 4. Just concentrate on the unit digits. That's it. 3971, 3971, 3971. Just look at the unit digits. That's it, nothing else. It again has a cyclicity of 4. Okay. Next one is 7. Now we are only concerned with unit digits, so probably I'll only write the unit digits. So it's 7, 49, 343, 2401. Now I'm not writing all the digits, it's not required. What now I'll be doing is I'll be multiplying 2401 by 7, right? So I don't know what will be the first 3 digits, and I'm not concerned with them also. I know that the last 2 digits will be 07. So I'll again have 7. Then 7 to the power 6. When I'm going to multiply 07 with 7, it will come out to be 49. So that's 49. So 49 will multiplied by 7. 9 into 7 is 63. I'm going to keep 3 and I'm going to carry over 6. 7 4s are 28. 28 and 4 is, 28 and 6 is 34. It's going to end in 43. Then 7 to the power 8. We're going to multiply this 43 by 7. 7 3s are 21. Keep 1, carry over 2. It will probably have 0, 1 or something. Now my only concern here is that what's my last digit? So 7, 9, 3, 1. Again 7, 9, 3, 1. Again it follows cyclicity of 4. It's following a cyclicity of 4. Again, so see, once you remember these, like for 2 it's 2, 4, 8, 6, for 3 it's 3, 9, 7, 1, for 7 it's 7, 9, 3, 1. Then the only thing you need to understand is how do we use the concept of cyclicity. Nothing else is required, right? Okay, now the last one that we have is that of 8. So we have 8 to the power 1, that is 8. 8 squared, that is 64. 8 cube, that is 512. 8 to the power 4, which is 4096. Now I'll only be writing the unit digits. So 4096 needs to be multiplied with 8. So 6 into 8 is 48. 4 will get carried over 9. 8 into 9 is 72 plus 4 that of carryover, so that's 76. So the number is going to end in 68. Then when you do 8 to the power 6, 8 into 8 is basically 64. So you're going to have 4 and you're going to carry over 6. So 8 into 6 is 48. 48 and 6 is 54. So again it's going to end in 44. Then 8 to the power 7, again you're going to multiply 4 by 8. 4 into 8 is 32. You're going to keep 2, carry over 3. 32 again, 8 into 4 is 32. 32 and 3 is 35. You're going to keep 5. And again 8 to the power 8. 8 into 2 is 16. So we're going to have 6. 1 is carried over. 8 5s are 40. 40 and 1 is 41. So that's 1. So again, if we see that, we'll realize that again 8 has a cyclicity again that of 4. 8, 4, 2, 6. 8, 4, 2, 6. 8, 4, 2, 6. 8, 4, 2, 6. So 0, 1, 5, 6 don't have any cyclicity. Their unit digits are always 0, 1, 5, 6. For 4 and 9, we have two cases. If the power is odd for 4, unit digit is 4. If the power is even, unit digit is 6. For 9, if the power is odd, unit digit is 9. For 9, if the power is even, unit digit is 1. Whereas 2, 3, 7 and 8 follow a cyclicity of 4. For 2, the unit digits are 2, 4, 8, 6. For 3, it's 3, 9, 7, 1. For 7, 7, 9, 3, 1. For 8, 8, 4, 2 and 6. Now the only question is how do we use them while solving the question? Alright. So let's jump to some questions. Let's see how we can solve them. So what's the unit digit of 23 to the power 7, 12 to the power 8 and 51 to the power 517 to the power 22? Now since we are concerned with the unit digit, so we'll only focus on the unit digit. The digits before unit digits are none of our concern, which means 2 carries no meaning for me, 1 carries no meaning for me, 51 carries no meaning for me, since I'm concerned only with the unit digit. So this becomes as good as 3 to the power 7 multiplied by 2 to the power 8 multiplied by 7 to the power 22. Now 3, 2 and 7, all of them follow the cyclicity of what? They follow a cyclicity of 4. So 3 to the power 7 is nothing but 3 to the power 4 plus 3. Now 4 plus 3, what do you mean by this? This basically means that you're going to complete a cycle of 4 once because you have a 4, and then in the next cycle you will only travel till 3. You're going to complete one entire cycle. In the next cycle you will only travel till the third power, which means as far as unit digit is concerned, this question is as good as 3 to the power 3, which is equal to 27, which means the unit digit is 7. So unit digit is 7. Now 2 to the power 8. So that's like 2 to the power 4 plus 4, or that's like 2 into 4, which means 2 complete cycles of 4. So what's 2 to the power 4? 2 to the power 4 is 16. So as far as unit digit is concerned, I can say that 2 to the power 8 will have the same unit digit as 2 to the power 4, and 2 to the power 4 is how much? That's 16. So unit digit is 6. Unit digit is 6. 7 to the power 22. That can be written as 7 to the power 5 into 4 plus 2. Now what do you mean by 7 to the power 5 into 4? 5 into 4 basically means you're going to have 5 cycles. You're going to have 5 cycles. 5 complete cycles. Now after you are done with 5 complete cycles, in the 6th cycle you'll only travel to the 2nd position. That means if you talk about 7 to the power 22, it's going to have the same unit digit as 7 square. It's going to have the same unit digit as 7 square. Now how much is 7 square? It's 49. So what's the unit digit? It's 9. So we can say that unit digit of this number is 7, unit digit of this number is 6, and unit digit of this number is 9. Now when we are going to multiply these three numbers, 23 to the power 7, 12 to the power 8 and 517 to the power 22, what we are looking for is only the unit digits. What we are looking for is only the unit digit. So how would we get the unit digit of this entire product? That is by multiplying the unit digit of these corresponding numbers. So it's 7 into 6 into 9. So 7 into 6 into 9. So 7 into 6 is 42. Unit digit is 2. Then 2 into 9 is 18. So unit digit is 8. So C here is basically your answer. That's how you use the concept of cyclicity and unit digit. Alright. Let's move on to the next one. So now you know how to use also. So pause the video and try this question, please. This is 177 entire to the power 28. Okay. So don't get confused that it's only on the. This is 177 entire to the power 28, 133 entire to the power 23. Alright, now again we know that 7 and 3 they follow a cyclicity, right? So if you talk about 177 to the power 28, as far as unit digit is concerned, this number is as good as 7 to the power 28. Which means this number is as good as 7 to the power 4 into 7. Which means 7 complete cycles. Which means 7 complete cycles. Which means as far as unit digit is concerned, the unit digit of this number is as good as 7 to the power 4. Now 7 to the power 4 has a unit digit of 1, which means unit digit of this number will also be 1. If we talk about 133 to the power 23, again we are talking only about unit digit. So this question is as good as 3 to the power 23, which is 3 to the power 4 into 5 plus 3. 5 complete cycles, and in the 6th cycle we'll only go till the 3rd position. In the 6th cycle we'll only go till the 3rd position. This is as good as 3 to the power 3. 3 to the power 3 is 27, so unit digit is 7. Which means when we'll expand this 177 to the power 28, the expansion is a very big number, in the end 1. And 133 to the power 23 will have an expansion of a very big number, in the end 7. Now don't write your answer as 6, it's incorrect. Because what you're doing is you're doing 1 minus 7. 1 minus 7 is not 6, it's minus 6, right? So don't commit that mistake. Now what exactly is going to happen here is that, so you have a number ending in 1, and from that you're subtracting a smaller number ending in 7. So how do you subtract? So you can't do 1 minus 7. So you'll take carryover. What you'll do is you'll take a carryover from the previous number. So when you'll take a carryover, instead of this one, it will become 11. So when you'll do 11 minus 7, this will simply be equal to 4. So what's the unit digit? The unit digit is 4. So C is your answer. Okay. All right. Okay, let's move on to the next one. Pause the video and try this question, please. All right, let's see what we can do. A and B are positive integers. X is equal to 4 to the power A, Y is equal to 9 to the power B, which of the following is a possible unit digit of X and Y. Now first let's concentrate on the possibilities of unit digit of 4 to the power A and 9 to the power B. If I talk about 4 to the power A, now since the number is 4, so we figured that out that, or we know that as far as 4 is concerned, we can have only two possibilities. If A is odd, then the unit digit is 4. If A is even, then the unit digit will be 6. These are the only two possibilities. Similarly, if B is odd, then the unit digit is 9. If B is even, then the unit digit is 1. These are the only possibilities that we can have. So we have two possibilities from A, two possibilities from B, which means a total of 4 possibilities when we'll multiply A and B. So 4 into 9 is 36, so we will have 6. 4 into 1 is 4, so we can have 4. 6 into 9 is 54, so again a 4. And 6 into 1 is 6, so again a 6. So there are only two possibilities as far as unit digit is concerned, that is 6 and 4. Now both of them cannot be part of our options. Only one of them will be part of our options because we don't have multiple answers. In this case, we don't have multiple answers. And of course, in case of GRE, you guys do have multiple answers. In case of GMAT, we don't have, right? Now, since we are discussing just the basic parts so that you get the concept, so I have not taken up any question where you can have multiple answers, right? So the only possibility that we have here is 4, which is option number B. That's it. Nothing else. Okay. All right. Let's move on to the next one. Pause the video and try this question. This one is quite interesting. Please give this one a try. Take your time. All right. Now, before we actually start solving this question, let me ask you something. If I have a number and if I divide it by 5 and if I want to figure out the remainder, how would you calculate it? For example, let's start with something small. Let's suppose if I give you 63 divided by 5 and if I ask you to calculate the remainder, what you'll do is you'll do the long division method. 5, 63, 1s are 5, 13, 2s are 10, 3, so remainder is 3. If I give you 197 divided by 5, what will be the remainder? You'll probably do the same thing again. That is 197, you have 5 here, so 5 3s are 15. You will have 47, so 5 9s are 45, and you will have remainder as 2. What if I tell you that you can find out your remainder just by looking at the question? That is, you don't even have to pick up your pen in order to calculate what will be the remainder when a number is divided by 5. What you typically have to do is a number is divided by 5 and if you want to calculate the remainder, just look at the unit digit. Just look at the unit digit. If the unit digit is less than 5, then the remainder is the unit digit. Like in this case of 63, 63 divided by 5, unit digit is 3. Unit digit of 63 is 3. Do it with any other number. For example, if you have 1991, if you do 1991 divided by 5, you'll find out that your remainder is 1. You can do the long division. Let's suppose you have 2964044 divided by 5. The remainder is 4. You can try the long division method. So if the unit digit is less than 5, then the remainder is always the unit digit. And the remainder is always the unit digit. Similarly, if the unit digit is 5, then the remainder is 0. If the unit digit is 5, then the remainder is 0. And if the unit digit is greater than 5, then the remainder is the unit digit. I'm writing that as UD minus 5. For example, check out the case of 197. Remainder came out to be 2. What is 2? It's 7 minus 5. That is 2. Right? And this will always happen. This will always happen. Because if you have a number, let's suppose I have a number A, B, C, D, E, F, let's suppose ending in X. So mathematically, I can rewrite this number as A, B, C, D, E, F multiplied by 10 plus X and divided by 5. Now, if this number is a multiple of 10, I'm only talking about A, B, C, D, E, F, not about X. If this number A, B, C, D, E, F, which is multiplied by 10, if this number is a multiple of 10, it has to be a multiple of 5. It has to be a multiple of 5. Which means I cannot have remainder from this part. Remainder will always be 0. If a number is multiple of 10, it has to be a multiple of 5. It's quite obvious. Remainder is always 0 from this part. Which means the only remainder that you're going to get is from X by 5. And X is what? X is the unit digit. X is the unit digit. So we have to use the same concept here also. Let's see how we can use that. So now we know the concepts. Let's try to use it. So basically this question is all about calculating the unit digit of 1 to the power 1, 2 squared, 3 cube, 4 to the power 4, 5 to the power 5, and so on and so forth. So 1 to the power 1 will give me unit digit as 1, 2 square is 4, it's going to give us 4, 3 cube is 27, it's going to give us 7, 4 to the power 4, 4 to the power even is going to give us 6, 5 raised to any power will always give us 5, 6 raised to any power will always give us 6, 7 to the power 7, 7 to the power 7 is as good as 7 to the power 4 plus 3. One complete cycle, second cycle up till third position. So that's 343. Unit digit is 3. 8 to the power 8. That means 2 complete cycles. So you're going to end up with 6. 9 to the power 9. 2 complete cycles. And then in the third cycle, you're only stuck with the first position. We don't even have to do this in case of 9. We have an odd power in case of 9. I'm really sorry. Odd power in case of 9 will always give you unit digit as 9. And then 10 to the power 10 will always give you unit digit as 0. That's it. Let's add these numbers. 1 and 4, 5. 5 and 7, 12. 12 and 6, 18. 18 and 5, 23, 23 and 6, 29, 29 and 9, 38, 38 and 9, 47, 47 plus 0 is 47. So what's the unit digit? Unit digit is 7. Unit digit is 7. Now if I'm going to multiply this by 5, what will be the remainder? Remainder will be 2. And that's your answer. 2 is your answer. Okay, so this is basically what is meant by when you say that how do you solve, or what are the types of questions of unit digit? These are the ones. Now what I have further done in this video is that I have taken up 2 questions on data sufficiency, which is for GMAT students, and I've taken 1 question on quantity comparison, that's for GRE. Okay, I'm going to start off with the 2 questions on GMAT, and then I'm going to go to the 1 question of GRE. So if you're in GRE aspirant, so you can skip these 2 questions, but I would still suggest you to have a look at these questions also, just so that you understand the working process, right? There is no harm in understanding 2 extra questions, right? All right, so let's begin. N is a positive integer. What is the remainder when 2 to the power n is divided by 10? Again, see, the way this question has been put up is that this question is not directly asking you what is the unit digit. They're not doing that. They have gone a step further. What they're basically saying is what is the remainder when 2 to the power n is divided by 10. Now if you have a number which is divided by 10, what will be its remainder? So let's suppose you have a very big number and it ends in x, and you are dividing this by 10, and if someone asks you to calculate the remainder, what would that be? Do we have to do the long division? No, we don't have to do that. That's the brilliant part about maths. If you understand it thoroughly, then you don't have to do all these things. If I have a number, let's say a, B, C, D, E, F, G, H, I, J, and divide by 10, find the remainder. Do I need to divide it? No, you don't have to. If you write this mathematically, then this number basically becomes A, B, C, D, E, F, G, H, I whole multiplied by 10 plus J divided by 10. For example, if I take up a number 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by 10, find the remainder. You can rewrite this number as 1, 2, 3, 4, 5, 6, 7, 8 whole multiplied by 10 plus 9 divided by 10. Now, is this number gonna give you any remainder when divided by 10? No. Similarly, is this number when divided by 10 is gonna give you any remainder? No, it won't. So from where will the remainder come from? It will come from the unit digit. So j by 10 will give you what as a remainder? It will give you j, whatever the value of j is. And of course, j is a digit, so it can't be greater than 10. It will always be between 0 to 9. In the second case, where we took the number to be 1, 2, 3, 4, 5, 6, 7, 8, 9, so we can say that our unit digit is simply 9. I don't even have to solve this because 9 by 10 will always give me remainder as 9. Now remember that whenever you calculate remainder, you always take quotient to be integer. Like there should not be any sort of a confusion that if you are doing 9 by 10, why isn't the answer is 0.9? If you are doing 0.9, that is if you are going to have your quotients in decimal, then the remainder is always 0. You only get remainder when the quotients are also integers, okay? So that's another thing which you need to understand. Anyways, so what's the remainder when 2 to the power n is divided by 10? That's another way of asking what's the unit digit of 2 to the power n. That's another way of asking what is the unit digit of 2 to the power n. Now if you talk about 2 to the power n, we have 2 possibilities. We can have unit digit as 2, 4, 8 and 6. These are the 4 possibilities. 2, 4, 8 and 6. So in the first case, remainder is 2. In the second case, it's 4. In the third case, it's 8. In the fourth case, it's 6. Now the first part is n is divisible by 2. If n is divisible by 2, then that means n has to be even, which means it can't be the first case, it can't be the third case. But we still have two options, that is 4 and 6. So does statement A give us a conclusive result? No, it does not. So according to the sequential order, A goes, D goes. Now statement B, n is divisible by 4. That means it's a multiple of 4. That means there is only one possibility, that is this one. The number will be in the form of 2 to the power 4k. And that will always give you unit digit as 6. So when the number is divided by 10, what's the unit digit? It's always 6. So is B giving me a conclusive answer? Yes, it is. Hence B is my answer. Hence B is my answer. Alright, let's move on to the next one. Alright, pause the video and try this question, please. So we have 243 to the power x, 463 to the power y is equal to n. X and y are positive integers. What is the unit digit of n? So 243 to the power x. Now since we are concerned with unit digit, so we will only be like, we are only concerned with 3 to the power x. Then we have 463 to the power y. Again, we are only concerned with 3 to the power y. We are only concerned with 3 to the power y. So what we need is, we need 3 to the power x, the unit digit of 3 to the power x, and we need the unit digit of 3 to the power y. Then we'll multiply these two unit digits. What we'll get is the unit digit of n. So what all possibilities can we have? So we can have x 1, 2, 3, 4 because 3 follows the cyclicity of 4. The unit digit of 3 follows the cyclicity of 4. So you can have unit digit as 3. You can have it as 9. You can have it as 7. You can have it as 1. Same thing goes with y. 3, 9, 7, 1. So this ought to be 7, not 9, my bad. So do we know the value of x and y? No, as of now we don't know that. So statement number 1 says x plus y is 7. Okay. So if x plus y is 7, what all we can have? We can have 1, 6. We can have 2, 5. We can have 3, 4. Now I'm not going the other way around. That is not, I'm not considering the ordered pairs. Why? The reason is both the numbers have their unit digit as 3, right? If both the numbers have their unit digit as 3, so whether I take x to be 1, y to be 6, or x to be 6, y to be 1, either way it's one and the same thing. It's not going to make much of a difference. Okay. So if x is 1, then unit digit is 3. If y is 6, 6 means 4 plus 2. One complete cycle, then you are stuck at the second position, that's 9. So for the first case, I'm going to have 3 into 9, which is 27, and that is 7. Second case, it's 2 and 5. So 2 means 3 squared, that's going to end up in 9. 5 means you're going to complete an entire cycle, then you're stuck at the first position for the second cycle. So again 9 and 3. So 9 and 3 is again going to give me 27, that's 7. Third is 3 and 4. 3 and 4. So 3 is going to give me 7. And 4 means you have completed this cycle, which means you are at 1. So it's going to give me 7 and 1. That's again 7. So interestingly, I'm getting my answer from first statement. Interestingly, I'm getting my answer from the first statement. Even though I have multiple options, but I'm still getting my answer as 7. Okay, so A is definitely my answer. So that means C, E, B goes. The only option that I can now have is A and D. Okay, now B says x is equal to 4. Now if x is equal to 4, do we know the value of y? No, we don't know that. If x is equal to 4, then the unit digit of 243 to the power x will always be equal to 1. But in this case, we still have 4 possibilities. In case of y, we still have 4 possibilities. So we can have 3, we can have 9, we can have 7, we can have 1. All of them are feasible. So second will not give me an answer, which means D is out, hence A is the correct answer. Again, going step by step, that's it. Alright, one last question, and that's for GRE aspirants. Again, the point of this question is just to make you understand the basics, that's it. Nothing else is my concern. Now you already know what do you mean by when remainder is divided by 10 and what do you mean by when remainder is divided by 5. Again, what we are looking for is the unit digit. So n can be 1, 2, 3, 4 because 2 and 7 both follow a cyclicity of 4. So if we talk about unit digit, let's talk about 2 to the power n. It will be 2, 4, 8, 6. 7 to the power n, it will be 7, 9, 3, 1. Right? These are the 4 unit digits for both the numbers 2 to the power n and 2 to the power n and 7 to the power n. 2 to the power n when divided by 10, if we talk about remainders, so 2, 4, 8 and 6. 2 will give you 2, 4 will give you 4, 8 will give you 8 and 6 will give you 6. In case of 5, 7 is gonna give us 2, right? 7 by 5, it will be 7 minus 5, that's 2. 9 by 5, it's gonna give us 4. So the first two are matching, the first two unit digits are matching, the first two remainders are matching, 2 and 5. Sorry, I think I have done one mistake, it will be 2 and 4, I'm sorry. 9 minus 5, that's 4, I'm sorry. So the first two are matching. What about the third one? 3 divided by 5, this will give you 3. This will give you 3. And divided by 1, this will give you 1. So we have the first two matching, but we don't have the last two which are matching. So do we have a conclusive result from this, like is quantity A bigger or is quantity B bigger, or are they both equal? In the first case, they both are equal. In the last two cases, quantity A is bigger. So that means we don't have any conclusive relationship between the two statements. Hence, the answer becomes D. Okay. So this is what last digit concept looks like, and these are the types of questions that you can expect in your exam. All right. So thank you so much guys for watching the video. Please subscribe to the channel for more videos and exam related content on GRE, GMAT and SAT. If you're looking for any personalized classes on the same, you can always get in touch with us. Okay. So you have our mail ID, you have our number also. Alright. Alright guys, thank you so much. Keep watching and keep learning, and please do share the videos with your friends also so that they can also learn what the types of questions that come in GRE and GMAT, right? Thank you so much. Keep watching and keep learning. Thank you so much guys.